Hello everyone, my name is Ashutosh Kulkarni and I will present our work titled DTMIR Pro Domain Translation with Prompt-Based Latent-Space Generalization for Multi-Weather Image Restoration. Let me begin with the motivation. In real-world applications such as surveillance, autonomous driving and robotics, vision systems often operate under adverse weather conditions. Haze reduces contrast and visibility, rain introduces streaks and veiling effects, snow creates opaque occlusions. However, in reality, degradations are rarely isolated. We often encounter mixed weather conditions, for example, rain with fog or snow with haze. Most existing approaches either train separate models for each weather type or rely on very large architectures. This increases computational costs and limits the generalization. So the key question we asked was, can we design a lightweight, unified framework that handles multiple weather conditions and generalizes to compound degradations? To answer this, we propose DTMIR Pro. Our framework has two main stages. First, prompted generalized domain translation, and second, multi-weather image restoration. Importantly, our entire model uses only 3.9 million parameters. So why domain translation? Multi-weather degradation is a complex and often mixed. If we directly train a restoration network on combined degradations, the model struggles to disentangle weather-specific patterns. Domain translation helps by generating structured weather variants such as haze, rain, and snow representations. This forces the network to learn discriminative weather-specific features before restoration. In short, domain translation simplifies a complex restoration problem into structured intermediate representation. Instead of training separate generators for haze, rain, and snow, we design a single translation network. This network is guided by what we call as weather-coded prompts. These are learnable prompt tensors and they are injected with simple one-hot weather code. This allows one network to translate an image into multiple weather domain variants. To further improve feature extraction, we introduce dynamic attention block. Unlike traditional attention mechanisms that use fixed convolution kernels, our block dynamically selects kernels based on the input features. As a result, for a single degraded input, we generate three translated versions: a hazy version, a rainy version, and a snowy version. These translations provide structured weather priors. Now, let me move to the restoration stage. Here, we introduce two key components. The first is similarity-based feature routing. We compute structural similarity between the input image and each translated version. The translation with lowest similarity indicates the dominant degradation. We then route encoder features from that translation branch into the restoration network. This makes the restoration process degradation aware without explicitly reprocessing the input. It also reduces redundancy and improves efficiency. The second component is multi-weather feature fusion. In real-world scenarios, weather degradations are often compound. So we fuse weather-specific features at two levels: at global level using frequency domain fusion and at the local level using multi-scale gated depthwise convolutions. This allows the model to learn combinations such as rain with hail or snow with fog. Together, these modules enable robust multi-weather restoration. Now let us discuss the results. Qualitatively, our method removes distant haze, suppresses rain streaks, and eliminates snow occlusions while preserving structural details. On quantitative results calculated on real-world datasets, we outperform the existing state-of-the-art methods in terms of NIQE, entropy, and BRISC. And on the synthetic datasets, we outperform the state-of-the-art methods in terms of PSNR and SSIM. And this is an ablation study that we perform with different types of domain translation settings. We also demonstrate that our framework generalizes beyond weather restoration. Underwater images suffer from severe color distortion and visibility loss. By reformulating underwater enhancement as domain translation problem, we learn structured color degraded variants and guide restoration accordingly. Finally, we evaluate the impact on downstream vision tasks. Using DTMIR Pro as a pre-processing step, we observe improved performance in depth estimation, object detection, and semantic segmentation. The restored images provide clearer structure and better feature extraction, leading to more reliable perception in adverse conditions. Thank you, and please scan the QR code for the GitHub repository.